Hello, and thank you for joining us in this video. I am Julien Mo, Senior Data Architect and CEO of FoxCub, a French company based in Paris. This video have been also prepared with Kevin Darty, one of my colleagues, and also with Shadia Kilouchi, which is the project coordinator of Sound of Life for CNRS and the UMR Passage Research Lab in France. Today, we are going to explore Sound of Life, a fair-oriented platform built to unlock the scientific and operational potential of environmental acoustic data. In this demo, we will walk you through the key features, challenges, and vision behind the platform. Every year, millions of environmental sounds are recorded by scientists, conservationists, and also by citizen observers alike. Yet, most of these recordings stay on personal drives, undocumented and disconnected from biodiversity infrastructures. They are not described, not shared, and not reused. Sound of Life wants to change that. It provides the structure, standards, and visibility needed to make acoustic data fair, I mean findable, accessible, interoperable, and reusable. By allying with Darwin Core and connecting to platforms like GBIF, it turns scattered sounds files into valuable biodiversity data. The Sounds of Life Consortium brings together over 12 leading French institutions, spanning biodiversity, ecoacoustics, geography, and digital humanities. Coordinated by UMR Passage and officially labeled by Humanum, the initiative builds a common foundation to scale up the use of environmental sound data. By allying with Darwin Core and GBIF, it ensures both interoperability and international visibility, while opening the way for collaborative annotation, AI-ready corpora, and new ways of exploring soundscapes. Sounds of Life started in 2023 to unite experts. After a first year focused on shared challenges, the project moved into its implementation phase, building a fair-ready infrastructure based on Darwin Core and aligned vocabularies. We are now prototyping tools to annotate, describe, and publish specialized bioacoustic data while preparing for long-term preservation and interdisciplinary reuse. From 2026, the aim is to scale, enable large-scale data ingestion, train AI models, and turn the platform into a sustainable, open research infrastructure for science, conservation, and policy. Let me give you a concrete example. Claire is a bioacoustic researcher in the Seven National Park in France. Since 2021, she has been collecting hundreds of hours of audio each week. Birds, insects, wind, even traffic. But all of it was cutted across drives and S3 buckets with no metadata, no standards, and no easy way to reuse it. With Sound of Life, Claire can now bring those recordings into a shared workspace, enrich them with structured metadata, annotate spectrograms with their team, and make the data fair and reusable for herself and the whole community. Let's see how it works. So this is the Sound of Life homepage. User logging with OrchID, Google, or AGI account, for example, then land in a personal workspace linked to their organization. They can create shared spaces, invite collaborators, and manage files together. Audio files can be uploaded by drag and drop via FTP or from an AWS S3 bucket for the moment. Here you can see I connect to my S3 to fetch files asynchronously. Once imported, they will appear in my personal directory. So this is the interface where I can check the progress of my deposits. And then I can see all of them in my personal space. And now I would like to share them with my colleagues. To make the data readable, I can add metadata during upload via a CSV mapping file. The platform reads this file and links the field to the Darwin core schema automatically. As you can see here, this is the extract from the CSV, and now I can adjust mappings, exclude properties, or edit values before confirming. Once ready, files are moved to a shared library. So you can see here the progress of my import. So my import from my personal space to the shared library with the other member of the collaborative workspace. In the shared view, you can see all metadata fields, both imported and edited. The platform flags issues like missing GBIF required fields and helps users fix them. Autocomplete on controlled vocabularies, taxonomies, traits, geonames, guide metadata entry, ensuring compliance with biodiversity standards. So the interface also highlights files required or recommended by GBIF. So as you can see here, we have a lot of properties for the Darwin core list of terms. So to help user to facilitate the exploration, we provide some presets or options in order to select what are the metadata we want to explore, complete, or add to our data. So we have also other functionalities to facilitate this approach. And now let's open a recording. So for example, this one, sounds of hummingbird. You will see the details of this record, and especially the waveform and the spectrogram. Visualization settings can be adjusted for better analysis. I can reprocess the spectrogram with custom parameters, then zoom into a time frequency window to annotate specific sound events. So annotations are flexible and collaborative, and you can adjust the different dimension of an annotation. I mean, for times and frequency. And all annotations are shared with your collaborators, and you can also add more than one annotation to the file. And once everything is ready, files can be grouped into datasets with their own GBIF compliant metadata, as you can see. And then this can be exported as Darwin Core archive, ready for publication and sharing across platforms. What you have seen is not just a prototype, it's built on real standards. We have aligned with Darwin Core on GBIF. Each recording is an event, each detection or each bioacoustic record is an occurrence, and metadata is enriched via some GBIF extensions. This modular setup lets us describe both soundscapes and species detections without changing core fields. The result? Data that is ready for GBIF, for analysis, and for AI, fully integrated into global biodiversity platforms. No need to reinvent the wheel, just make it work for sound. Standards are powerful, but not magic. Darwin Core gave us a solid base, but also forced us to rethink things. For example, one file equals one occurrence, so multi-species recordings quickly get complex. We also needed over 60 controlled fields for taxonomy, location, traits, which added complexity to forms and validation. But in the end, the challenges help us design something stronger, fair, and actually workable. What we have shown today is not just a platform. Sound of Life is a community effort. a way to bring structure, meaning, and standard to something that was until now invisible, the acoustic dimension of biodiversity. Thanks a lot for your attention. Feel free to contact us if you have some questions, and see you soon or later in another session. Thanks again.